mathy words that we have here, interpolate and extrapolate. You might have heard extrapolate before, but probably interpolate you haven't. Interpolate is, it's when we pick a point on the graph. It might not be a specific data point, but it's within the graph that we've graphed. To extrapolate means to make a reasonable guess, a reasonable mathematical guess. Good morning. Outside the graph. So inside, extra, outside. So interpolate, we're picking a point somewhere on the graph that we're given. Extrapolate means we're going to make a prediction off the graph. Like we kind of did that with our table of values when we found the pattern and we kept going. It wasn't a number in the table, but we were able to figure out what it would be. Okay, so we have the graph of a car journey. So we have each axis labeled. So our x-axis, we have time, and time is measured in hours. And on our y-axis, we have distance, and it's measured in kilometers. So this graph shows the distance traveled by the car on the highway, changes over a 4-hour period. We've been given data so at 0, 1 hour, 2 hours, 3 hours, 4 hours. So it's given us that 4-hour period. We plotted the information, and we can use interpolation to estimate the values between two data points given. So if we want to estimate 1.5 hours, now we were given data points at 1 and at 2. We weren't given data points at 1.5, but we have the line and we can make an educated guess. So you go over to 1.5 here, and you go up to the line. You go up to the line right there. And then you track over to where we are on the y-axis. So how far have we gone in an hour and a half? What do you guys think? Looking at that graph. We know that this is 150. That line there is 150. Oh, that's really tiny. Because between 100 and 200 is 150. So we know it has to be below 150. So this one said approximately 120 kilometers. Okay, so how far did we go, or how long does it take us to travel 300 kilometers? So if we have the kilometers, we go here, we track across to the graph. Once we hit the graph, we go down. So how long do you guys think it took to travel 300 kilometers? What do you know? What do you know this little line is right there? That's halfway in between 3 and 4, so it's 3.5. So we know that this would hit the x-axis between 3.5 and 4. What's your estimate? Anybody? Anybody feel confident? What's greater than 3.5, but less than 4? Give me a value. No, because 345 is a little less than a half, so maybe 3.75, right? Maybe this point here would be 3.75 hours. I think maybe, Reagan, you were right. You were talking in minutes, and I was talking in decimals. Yeah, so 3 hours and 45 minutes, which is 3.75. Sorry, you were right. That was a good estimation. Okay, so that's how you do it when you have the graph and the data on the graph. Now, it's got to be an educated estimate. You can't just randomly pick like, oh, 300 kilometers is going to take me 2 hours. Well, that's not a true story. At 2 hours, you've only gone 150 kilometers, right? Just a little bit more than 150. So how could you go 2 hours would get you 300 kilometers? Like, you have to use the data. You can't just randomly pick a number. So interpolate, it's estimating the value between two given values. So we have it on the graph. And we'd only interpolate when it makes sense to have values in between. So like people, we remember that's discrete data. We don't want to have half a person or 5.4 people. So sometimes you can't interpolate data. All right, now we're going to extrapolate. So now we're going off the graph. We're going off the graph. Okay, suppose the car maintains the same average speed, so it's the exact same graph. We have the data points here, so we have 1 hour, 2 hour, 3 hour, 4 hour, okay? We can extend the graph, so you can extend the graph to predict how far the car will travel in a given period of time or distance. So when you have to extend the graph or go off the graph to make your estimation, that's an extrapolate. We'd use a ruler because we know it's a straight line. We know that that's a linear relation because it's a straight line. To estimate the time it takes to travel 450 kilometers, we would have to extend the line. Like, we couldn't stop here. So we would get our handy dandy ruler and extend it, and this graph is already done for us. So it would just extend. So we're going to go to 450, go to the line, and then we're going to go down. So it's a little bit more than 5.5 hours, so maybe 5.6 hours, something like that. So extrapolate, you're going to go beyond the data given. You might go off the graph. You might have to extend the graph. Interpolate's a little bit easier because you're looking at the graph you've already graphed. Extrapolate, we have to do a little bit extra work. Okay, let's see what you know. We got an altitude. What's happening? Let's look at this graph. Altitude is how high we are off the ground, and time. So what's happening as time goes on? What's happening to our altitude? It's going down. So what's happening with the plane? It's probably getting ready to land, right? Like, it's coming closer to the ground. This graph shows the plane's altitudes. Oh, look, as it lands. The relationship between altitude and time is approximately linear, so it's going to be an approximate straight line. What was the plane's approximate? So that's a good giveaway that we're going to be doing an estimate. Doesn't have to be exact, but it's got to be pretty close, and it has to be educated. You can't just make random numbers. So what was the plane's approximate altitude at 50 seconds? Good morning. At 50 seconds. Anybody feel confident to say an estimate? You got to look at the graph. So what are we going to do? We're talking about seconds. So we're going to go over to 50. So there's 40, there's 60. 50 is right here. We're going to go up to the line, and then we're going to go. So what do you guys think at 50 seconds, how high was the plane in kilometers? Was it at 10? Pretty close to 10. Was it exactly at 10? It's a little bit below, so maybe 9? 9.5? I'm going to say 9 kilometers. So if you gave me something in that range, I would mark it as right. So if you said 9.25, 9.5, if somebody said 10, I might be a little, it's not exactly on the 10 line. So I don't know if I would accept 10 as an answer, but you got to be close. Would 25 kilometers make sense here? Where's 25? Right up there. Is that anywhere near there? Did the plane even get to 25? It did not. Okay, what was the time that the plane's altitude was approximately 11 kilometers? All right, so the altitude is 11 kilometers, so I'm going to go across just above 11, or just above 10, sorry, to the line. And then once I hit the line, I'm going to go down. So what would you guys say was the time it took to hit 11 kilometers? 50 is this mark right here. 50 is the darker pink mark. And we're somewhere in between 40 and 50. So what would be a good answer? 45, great answer. So, but it's going to be 45. Our time is measured in seconds. So I need my units of measure on here as well. Is it appropriate to join the points with a straight line? Is this data discrete or continuous? Can I have parts of a kilometer? Yeah, I can tell you to go walk 1.5 kilometers if you want. Can I have parts of time? Can I have half a second? Yeah. So if I can have parts, that means that the data is continuous. Data is continuous. What are things that we wouldn't connect? What are things that we wouldn't connect? Could we have half of a kitten? No, don't do that. That's gross. Could we have half of a cookie? Like, would we sell half of a cookie in the cafeteria? Probably not. We usually sell cookies by the whole cookie, right? Depends on the context. Maybe I'm sharing cookies. I don't know. So there's some cases where it could be both. People are not good to cut in parts. Tickets. We usually don't sell half a ticket to a concert. You only get to stay for like an hour. You can't stay for the last little bit. So things like that. Things you can't cut into pieces, we do not connect the points. That data is called discrete. And we did that in our very first lesson. So if you need to know where that is. So that's it, ladies and gentlemen. Oh, not it. I was all excited. I thought, oh, look at that, we're done. We are not done. There's lots more examples to go. Okay. The value of the computer decreases over time. That makes sense, right? The phones that we own right now, in a couple of years, they won't be worth as much as we paid for them. After what approximate period of time does the computer have no value? It's worth $0. So no value. It's worth nothing. I got an old first generation iPhone SE at my house. If I tried to sell it on Thompson Buy-Sell Trade, how much do you think I'd get for it? Probably nothing. It's probably not worth very much. It's not the second generation SE. It's like the very first. It's like little tiny. It's got a crappy camera in it. So here we don't know the $0 values right here at the corner, right on this line. So we don't actually know. So what we're going to do is we're going to take a ruler and we are going to extend this. We are going to extend this line till it reaches the bottom there. All right. So when does the computer have no value? When does the computer have no value? When does it have no value, folks? It's right on a number. Really easy to see. 5 years. And don't forget, we have to put the units of measure. It's not 5 weeks. It's not 5 decades. It's 5 years. When was the computer worth $200? When should I have sold my computer? So we're going to go to the 200 mark. We're going to go over to our line. When we hit the line, we're going to go down. So what year should I have sold it for $200? 4. I waited too long. Is it appropriate to join the points on this? Can I have parts of a year? Yeah. Can I have parts of money? Can I have parts of a dollar? Yeah. So we would say the data is continuous. So I think if I were making a cheat sheet, I definitely put something about data being continuous and discrete, because that will definitely be a question. And I'll be looking for you guys to be able to graph as well. So if you haven't practiced your graphing yet, I would definitely try that, just so you've got a little bit of practice before you get to your problem set tomorrow. All right, so those were all situations, those were all things that made sense. We talked about money, we talked about time, we talked about altitude. Now we're going to talk about a graph that doesn't have any context. We don't know if it's money or time or tickets or puppy dogs. We know nothing about it. We just have a graph here. So it says determine the value of x when y is equal to 3. So y being 3, we're looking at the vertical axis. So we're going to go to the vertical axis and we're going to go to 3. Okay, you guys agree that 3 would be there, right? Yes? And we have to go over to the line. So would I go left or would I go right? That's right and that's left. Where am I going to hit the line? Would I travel this way or would I travel this way? So would I travel to the left or would I travel to the right? I hope to the left. If I travel to the right, like if I put my line here, what do you notice about the space between this line and the graph? It's getting bigger, right? So I'll never ever touch it. But if I go this way, it's like you'll never touch it either. It's not there. So this is when I have to extend this one as well. And we kind of see where they cross. This is going off the graph. This is going beyond the data. So where do you guys think x will be? X will be 3. Where do you think that will happen? Because we need to come down to our x-axis, which is right here. So I'm kind of extending it off. What do you guys know? This would be -3. That would be -4. Would it be -5? Would it be -6? What do you guys think? I think -6 too. I think that's a reasonable answer. It's kind of off the graph. There might be 5 in here, and then this would be -6. So we would say that when y is equal to -3, x is equal to -6. Okay, so what we just did was we extrapolated. We were off the graph, we had to kind of draw some lines, we had to figure it out. Now we're looking for where x is 5. X is 5. So what's y when x is 5? So we're going to go over to 5, and we're going to draw a line up till we hit the line, till we hit the graph, and then we're going to come across to our y-axis. So what do you think y is when x is 5? 6 point who? I like it. Yep, that sounds great. Y is equal to 6.5, and that's positive. So when we get a graph, lots of times I'll draw all over mine. I'll have my ruler, I will extend my lines, I will draw these little dash lines over it. It helps me. I'm a much more visual person, like I have to draw in the lines. Some of you guys are super visual thinkers and you don't need the lines to see it. I do. That helps my brain. It doesn't mean anybody's smarter than anybody else. It just means we think about it differently. Okay, does that make sense to you guys? Sort of, kind of? This one is about working with graphs and trying different things. All right, here we go. On a graph, you can use a line to interpolate values between the unknown points. Okay, this is just kind of a summary of what we're doing. So interpolate means we're on the graph, right? We're doing an estimate between data points we know. Super easy. I think to interpolate is easier than to extrapolate. And then once you extrapolate, sometimes you have to extend that line. Sometimes you have to extend both the lines that you might need. So that's what you're going to be doing. Interpolation and extrapolation should only be used when it's reasonable to have values in between or beyond the values on the, so that's talking about continuous. Oh, I highlighted things and I couldn't even show you. That's talking about continuous and discrete data. Okay. That's really it. There was just a couple more examples. So these are key points. This isn't anything that we have to find on here. This is just key points, reminding us how to do it. So things I think you should do for the rest of this period is if you have not graphed, if you have not done 5.2, you really need to work on that this period. Okay, so if you haven't done 5.2, the graphing, I would highly encourage you to practice that before you start today's assignment.